Continuing with the Chapter 6 test from 2019, this is page number 2. Question 5 said solve for y. There was a part A, B, and C. So our goal here is to get the value of the variable y isolated on one side of the equation. It may be that there's no other variables and it's just going to give me a numerical answer. It may be that there's other variables and I would get an expression for an answer. So let's start with part A. When I solve this for y, I can see on the left hand side I have a binomial times a binomial, so I need to get that product. I know that this is equal to y squared, and then there is a plus a 3y plus 2y and then plus 6. If you don't know where those parts come from, talk to me and make sure we look at an area model for representing that. That could be simplified further. It is y squared plus 5y and then plus 6, and maybe you know that. Of course you know that. And then on the left hand side, right hand side rather, I'm going to distribute this negative symbol across this product. So the opposite of something is the same thing as -1 times that thing. So I'm just going to multiply each of these by -1. So over on the right hand side, this is going to become a -2y, a plus 7y, and then plus a y squared. And we can see right now that on both sides, both of these have a y squared that I may subtract from both sides of the equation. It's gone. And I did a terrible thing. There's no y here, right? So this is just going to be a plus 7. For those of you that noticed that and were screaming at your phone, I'm sorry. I'm a little slow sometimes, especially when it's this late at night. Let's see, I'm going to add 2y to both sides, so this is going to become 7y plus 6 equals the number 7. And then I'm going to subtract 6 from both sides. And if I subtract 6 from both sides, I get that 7y is 1, and when I divide both sides by 7, I get that y is equal to 1/7. Now, if I want to check that pretty efficiently, I might choose to use my calculator, and in fact, I might even represent that fraction, that answer as a fraction. So, for example, I could hit second, nope, not that. It's alpha f1, and then just grab the fraction template. So here's 1/7, nice. And then in parentheses, I'm just going to go grab the 1/7 and plus 3, close it, and then I'm going to go grab the 1/7 plus 2, grab it, and then plus 2 and close that. And you can see on the left hand side of the equation it becomes 330 over the number 49. Let's see what the right hand side becomes with that value. So on the right hand side it is the opposite of, notice I'm using this button on my keyboard to get it, so I'm hitting the opposite of, and then open parentheses, 2 times, go grab that 1/7, there it is, and then minus the number 7. I close the parentheses, and now I need to go grab the 1/7, and I need to, oh, I forgot to add, oops, my bad. I have to hit plus, there we go, so plus 1/7, and then I need to raise that to the second power. I need to square 1/7. When I do that, you can see I also get 330 over 49. So this is my solution, right, for the very simple reason that it is a value of x that made both the left hand side and the right hand side truly the same. Let's move on to the next question, B. Solve for y. Okay, I'm going to distribute this -2 here, so this is going to become a positive 6y, and then minus the number 10, and then plus 8, and then minus 4y, and that equals 20. So when I combine up my like terms here, I've got the 6y and the minus 4y, which would give me 2y, and a -10 and a plus 8 would give me a -2, and that is going to equal the number 20. And then finally, let's add 2 to both sides, so I get that 2y is equal to 22, therefore y is 11. And I feel pretty good about that answer, but it's always worth checking, especially an answer that's a whole number like that. So let me again grab my calculator and just verify that this is, oops. So I'm just going to go negative 2 times, I'll open parentheses, a negative 3 times 11. Yeah, this is the answer. Plus 5, close the parentheses, plus 8, and then minus 4 times the 11 again. When I do that, surprise, surprise, I get 20, which is what the other side is. So definitely when x, or y rather, is 11, it makes both the right hand side and the left hand side equal to 20. Of course, the right hand side always is 20, but I digress. Last question, solve for y. And you can see that this has the value of x in one spot, right? There's 12 x's over here, so my answer will involve x. I'm going to go ahead and begin by distributing on the right hand side. A negative 2 times y is going to be negative 2y, and a negative 2 times 5 would be negative 10. On the other side, I had the 12x minus 4y. I'm going to add 4y to both sides, so I get 12 times x equals, let's see, if I add 4y to both sides, there are no y's left on the left-hand side, and a negative 2y plus 4y would give me 2y on this side minus 10. I'll add 10 to both sides, so 12x plus, there it got 10 added too, and then 2y, and then notice I'm not writing anything here because negative 10 plus 10 is 0. And then as a final step, I'm going to divide everything by 2. 12x divided by 2 is 6x, and 10 divided by 2 is 5, and 2y divided by 2 is y. So the equation we get here is that y is equal to 6 times x, and then plus 5. A little bit more difficult to check because it is an equation. There's lots of xy pairs that make this true. One thing I know is that if I find an xy pair that makes this equation true, it should also make the original equation true. But and you could pick a few of those, but it's not quite as ironclad as checking in the case of A and B. All right, let's move on to question 6. It says Russell is given a recursive definition for a geometric sequence where the first term is 1/9, and the next term, you can see it's like the next term, the one that comes after the first term, or no, this says the next term in a sequence is what the current term is times 3 more. So I keep multiplying by 3. And then it says give the first 4 terms of the sequence. Well, they tell me that the first term, right, is the first a of 1 is 1/9. So 1/9 is the first term. And now I'm going to multiply that by 3. Now, when I multiply 1/9 times 3, I get 3/9. That does reduce to 1/3. So I'm going to write it as 1/3. And you know, one of the things also, I mean, arithmetic's great, but you could offload that and look at this with your calculator also. So if I go and grab a fraction template, and here's my 1/9, and I'm just going to hit times the 3. Doop, you can see that right side is 1/3 times by 3. Oh, guess what? 1/3 times 3 is, it's the number 1. Yeah, times by 3 is going to be alright. Mr. Roberts, are you just now multiplying 1 times 3 on your calculator to verify that it's 3? Yes, I did. Yes, I did. You can see that I'm very, very sad. But not really. Okay, so those are the first 4 terms. We got 1/9, 1/3, 1, and 3. The next one after that would be 9, and then we'd get, 9 times 3 is 27, and then 81, etc. The final thing for this question says write the explicit equation for this sequence. So up here again, this was the recursive definition, right? The recursive definition tells you what one of the terms is. It tells you here the first term is 1/9, and it tells you how to get more. It says to get the next one, take the one that you're at and multiply by 3. It's so nice that they tell me that. That's the recursive definition. The explicit one says, look, if you want to know what any particular term is, you just put in the one that you want. I'll tell you it. On this one, to get the explicit equation, it's the same thing as the problem on the previous page. You need to know what the 0th term is, and then you need to know what your multiplier raised to the power is. So my 0th term in this case would have to be 1 over 27, right? Because to go forward, I'm multiplying by 3. To go backwards, I put more factors of 3 in the denominator. I'm dividing by 3. So it starts out with 1/27. Right? I divided 1/9 by 3, and then I'm going to multiply that times 3 raised to the nth power. And again, I will demonstrate the beauty of this sequence, how it works. So, in fact, I'm even going to use the fraction key again. It's so much fun to do this. So, grab that thing and go 1 over the number 27, and then I got times 3, and I'm going to raise that to a power. So, when I put the number 1 in there, it's like, ta-da! It's 1/9. Yeah, we're not surprised. If I put the number 2 in there, it's like, ta-da, 1/3, right? And if I put the number 4 in there, right, when I raise it, that I put to the 4th power, I get the answer 3 out of that. So that's my sequence, 1/27 times 3 raised to the nth power. Right. Ooh, the font is a little dark here. I don't know why that's kind of gray. So it says the longest side of a triangle is 3 centimeters longer than twice the length of the shortest side. All right, so then it says the third side is twice as long as the shortest side. The perimeter of the triangle is 88 centimeters. Draw a diagram and calculate the length of each side of the triangle. And also there's this very important let statement. Let S be the length of the shortest side of the triangle. So I'm going to, for my own convenience, just visually say, well, this looks like the shortest side, so I'm just going to call this S. And the longest side looks like this one. I don't think this is the right triangle, but it looks like it's the longest side. And it says, remember, the longest side of a triangle is 3 centimeters longer than twice the length of the shortest side. So here's twice the length of the shortest side, and I've got 3 centimeters more than that. It's terrible how I wrote that. Let me write it on the diagonals. Here's twice the length of the shortest side and 3 centimeters more than that. So 2s plus 3. And then it says, well, it says the third side is twice as long as the shortest side. So this third side is just going to be 2 times s. So of course the perimeter is the sum of these 1, 2, 3 different sides. So I can write the s, which is my shortest side, plus 2 times s, which is the medium sized side, and then plus 2s plus 3 more. That's the perimeter, and I'm told the perimeter is 88. So just simplifying this, I've got an s plus 2s, which is 3s, 3, 4, 5s, so 5 times s, 5 times s plus 3 is 88. If I subtract 3 from both sides, I get 5 times s is the number, what, 85? Of course, Mr. Roberts, 85. And if I divide both sides by 5, I get that s, the shortest side, is 17. So my answer would be the shortest side. It says the lengths of the 3 sides are, what were the units of this? These were given in centimeters. That's important. So my sides are I've got 17 centimeters. That's the shortest side. And then the next side, the next one up from that, would be twice that, so it would be 34 centimeters. And then the longest side would be 3 more than twice it, so that should be 37 centimeters. And of course, an important check here is that those 3 numbers should add up to 88. And in my mental state, I'm just going to do the 17 plus the 34 plus the 37 is indeed 88. So this answer checks nicely for us. So that's the end of page 2 of this test.